October, November 2024, paper 2, variant 1. Kindly, all of you, take your papers out and calculators and hopefully a brain. Chalo, let's start. A trolley of mass 0.2 kg is at rest. Perfect. So your initial velocity is 0 on a frictionless surface. Perfect. On a frictionless. Yes. We will do the complete paper. A block of wood is attached to the trolley. The volume of the block of wood is this. Perfect. This is the volume of the block of wood. Okay. And the density of the block of wood is this. Perfect. Calculate the combined mass of the trolley and the block. Wow, what a good question. Can we utilize the volume of the wood and the density of the wood to calculate the mass of the wood? Mass of the wood will be equal to what? Density of the wood multiplied by the volume of the wood. What is the density of the wood? 650. What is the volume of the wood? 0.0012. Can you calculate the mass here? 650 into 0.0012. This comes out to be 0.78 kgs. Perfect. The 0.78 kgs is the mass of what? Mass of wood. What is the mass of the trolley? Can anyone identify the mass of the trolley as well? The mass of the trolley is 0.2. We will add them together to get the combined mass, that is 0.8. So let's do that as well. 0.78 plus 0.2. This comes out to be 0.98 kgs. Perfect. Let's write it here 0.98 kgs. Let's further move ahead. 1 second. Yep, very good. Let's see this. Figure 1.1 shows that a student attaches a spring of spring constant 14. Okay, so this is the spring constant 14 to the front of the trolley. Perfect. You are attaching a spring of spring constant 14 Newton slash meter to the trolley. Perfect. The student holds the trolley and block and stretches the spring. Perfect. So the student is holding this trolley, this block, and it is stretching the spring. Perfect. He releases the trolley and block. The trolley and block accelerate from rest. Okay, so your initial velocity was 0. Perfect. As the trolley and block accelerate, the student keeps the extension of the spring at this. Perfect. The extension of the spring is at this. Perfect. Calculate the force exerted by the spring on the trolley. Can we calculate the force exerted by the spring? Force of a spring is equals to K into E. What is your K? 14. What is your extension? 0.035. Can you calculate the force? Anyone with a good enough calculator would be able to do this. This comes out to be 0.49 Newton. Perfect. The trolley and a block are pulled a distance of 0.8 meters by the spring. Perfect. Calculate the work done on the trolley. Okay, now you have to calculate the work done on the trolley. What is the formula of work done, beta? Work done का formula क्या होता था? Force into the direction या distance traveled in the direction of force. What is force? 0.49. What is the distance traveled in the direction of the force? 0.86. What does your work done comes out to be? What does your work done come out to be? 0.42 joules. Okay. Now let's further move ahead. Explain why the power transfer to the trolley and block increases as speed increases. Does anyone remember the formulas for power? Hmm. Yep. Why does the power increases as the speed of the trolley and the block increases? थोड़ा सा बच्चों यहाँ पे दिमाग लगाना है. You have to थोड़ा सा think out of the box. If you notice, power will have a formula of what? Power is equals to work done over time. And how can you break work done down? Work done is equals to force into distance over time. Now, do you realize, Peter, please Realize this. If you increase the speed, what will happen? If you increase the speed of the trolley and the block, the distance covered in 1 second will increase. If the distance increases, it causes the work done to increase, hence the power increases. So you can write it in a neat and good format here. You can say as speed increases, what happens? Distance traveled per unit time. This is how you answer right in the examination. Per unit time increases. And as distance traveled increases, what happens? Work done increases. And as work done increases, power increases. Is the first question clear to all of you? A student makes a ball from molding clay. The ball has a mass of 0.2 kg. Perfect. She drops the ball from a height of 40 meter above the ground. So basically, the ball is something like this. It is at a height of what? 40 meters above the ground. The mass of the ball is 0.2 kg. Can you calculate the initial gravitational potential energy? Yes. See, he is giving you 2 marks. भाई examiner बहुत ही kind हुआ है आज. Examiner has been too kind towards you. He is giving you the 2 marks for just calculating mgh gravitational potential energy का formula लगाने के 2 marks दे रहा है. So let's apply that formula. What is the mass? 0.2. What is G? 9.81. What is height? 40. Can anyone, sorry, 9.8. You will use 9.8 as your gravitational field strength throughout your O levels or IGCSE paper. This comes out to be 78 joules. Perfect. Now, calculate the speed of the ball immediately before the ball hits the ground. Ignore the effect of air resistance. Okay, so basically, what is happening? As the ball is moving down, as the ball is moving down, the gravitational potential energy is getting converted into kinetic energy. What was your gravitational potential energy? 78. What is the formula of kinetic energy? 1 upon 2 into the mass, that is 0.2, into the velocity square. Can you guys calculate the velocity? Pretty easy to calculate. 2 into 78 divided by 0.2 taken under root will give you your velocity. The velocity comes out to be what? Can anyone calculate it? The velocity comes out to be 28 ms minus 1. Simple, nothing complicated here. कुछ भी complicated नहीं है. चलो. Let's move ahead. Let's move on to part B. When the ball hits the ground, it stops moving. Perfect. If it stops moving, what has happened? Your velocity has become zero. And if your velocity becomes zero, your kinetic energy will become zero. Perfect. The kinetic energy of the ball is transferred to internal energy. Okay, so the kinetic energy is transferred to internal energy. Perfect. The temperature of the ball increases. Okay. Just keep on listening what is happening. The specific heat capacity, that is a small c, of the molding clay is 1400. Calculate the maximum possible temperature increase of the ball. Show your working. Which formula will we apply here? We will say Q is equals to mc delta T. What is Q? Q is the initial energy, that is 78. So let's place it here. 78. What is the mass of the molding clay? What is the mass of the molding clay? 0.2. Perfect. What is the specific heat capacity? 1400. Can you calculate the maximum temperature increase? Can you calculate the maximum temperature increase? Yes. 78 divided by 0.2 into 1400. This is your temperature change. Can you guys calculate this? Can you guys calculate this maximum temperature change? Any geniuses in the chat who would like to give the answer to this? By calculator, may you just have to put these values 78 divided by 0.2 into 1400. This comes out to be 0.28 degree centigrade. Simple as that, nothing complicated here. कुछ complicated नहीं. Suggests one reason why the actual temperature increase of the ball may be smaller than the value calculated in B part 1. Beta, why will the actual temperature be lower than the one which we have calculated here? Hmm. Any ideas? Do you see this statement? ये statement देख रहे हो यहाँ पे? Ignore the effects of air resistance. So it is possible that when the ball is moving from the top, it is possible that when the ball is moving from the top, when the gravitational potential energy is getting converted into kinetic energy, some energy is lost as work done against air resistance. So you can write it here. You can write this for 1 mark. Some energy, some energy. Now, please look how I'm writing the answers. थोड़ा सा understand करने की कोशिश करो. Subconsciously इस तरह ही answer देना है, you guys. Some energy is lost as work done against air resistance. This causes the change in internal energy. This causes the change in internal energy to decrease, and as internal energy decreases, change in temperature decreases. Nothing complicated. And what I am referring to as internal energy, beta, this Q. This Q is your internal energy. जैसे ही Q decrease होगा, you can see as Q decreases, your change in temperature will also decrease. Now, figure 3.1 shows a gas at room temperature. Perfect. So this is a gas at room temperature. The gas is trapped in a metal cylinder by a metal piston fixed in position. Perfect, perfect. The metal cylinder is immersed in boiling water and the temperature of the trapped gas increases. Okay. So your temperature is increasing. Perfect. Explain in terms of electrons and atoms of the metal how thermal energy is transferred through the walls of the metal cylinder. Frequently asked question. If I were you, I would have written this down in a register. अगला जो मैं आंसर लिखवाने जा रहा हूँ, I would have written this down in a register because this is a frequently asked question. ये तकरीबन 1 साल 1.5 साल में हर वेरिएंट में रिपीट होता है. So what is the examiner actually asking? How is thermal energy transferred in a metal cylinder? बेटा मेटल सिलेंडर में थर्मल एनर्जी किस तरह ट्रांसफर होती है? What happens in a metal cylinder? How does metal cylinders transfer thermal energy? Now, what will we say here? We will say, we will say, एक सेकंड, किसी का कोई आंसर है पहले? कंडक्शन अकर्स. बेटा इफ यू राइट कंडक्शन अकर्स 1 मार्क मिलेगा 3 में से. इफ यू राइट कंडक्शन अकर्स यू विल ओनली गेट 1 मार्क आउट ऑफ 3. यू हैव टू राइट इट इन अ प्रॉपर मैनर. वेन एवर यू हैव अ 3 मार्कर क्वेश्चन, समझ जाओ, you have to write it in great detail. Firstly, you will say due to the thermal energy, due to the thermal energy, or you can say increase in temperature, increase in temperature, the molecules start vibrating. The molecules start vibrating. Perfect. Just listen carefully what I'm trying to say. Start vibrating. These vibrating molecules, these vibrating molecules collide with the free electrons. और सिर्फ electrons भी लिखना चाह रहे हो, that's also correct. With the free electrons. These electrons, these electrons move along the metal, move along the metal and collide with other molecules. These electrons move along the metal. These electrons move along the metal and interact with other distant molecules or कह सकते हो atom. And these electrons move along the metal and collide with other molecules. Other इसको और इस तरह लिख सकते हो, other distant molecules, distant molecules. This transfers thermal energy throughout the metal, throughout the metal, throughout the metal. If someone is still confused कि क्या होता है, let me draw a diagram as well. Beta, you have molecules in a metal like this, like this. What electrons do is electrons एक molecule से hit करते हैं, they take its thermal energy, then move along and provide it to the molecule at the further end. Simple as that. The piston is fixed in position so that the pressure of the gas increases as the temperature increases. Perfect. So the pressure is increasing as the temperature is increasing. State what happens to the motion of the particles of the gas as temperature increases. बेटा मोशन को क्या होता है as temperature increases? Do have I told you one simple key point? Temperature is directly proportional to kinetic energy. As temperature increases, kinetic energy will increase and the velocity of the particles will increase. So you can write it here. The kinetic energy, the kinetic energy of particles increase and they move with a faster speed. And they move with a faster speed. Perfect. Let's move on to the next one. Bhai. Explain in terms of particles, perfect, why the pressure the gas exerts on the wall of metal cylinder increases as temperature increases. This is also an FAQ. This is also a star question. Why the pressure increases as temperature increases? Very, very easy. Very easy. You will say the particles collide more frequently, more frequently with the walls of the container, with the walls of the container. As they collide more frequently, what will happen? Any geniuses in the chat? As they collide more frequently, what will happen? As they collide more frequently, they exert a greater force. They exert a greater force. Hence, this greater force per unit area leads to a greater pressure, leads to a greater pressure. Nothing complicated here. Chalo, let's further move ahead. The gas in the cylinder reaches a temperature of 100 degrees centigrade. The piston is released and moved to the right. Okay, the temperature remains at 100 degrees centigrade. Now, can you see what is happening, beta? देखो बहुत ही इंटरेस्टिंग शिफ्ट हुआ है यहाँ पे. Initially, what was happening? The volume was fixed. Initially, volume was constant and pressure was directly proportional to temperature. Now, in this part C, the temperature has become constant. Temperature constant हो गया. What will happen? If temperature becomes constant, pressure and volume become inversely proportional. This is known as Boyle's law. This is known as Boyle's law. Simple as that. Nothing complicated. I think आगे भी उसने यही लिखा हुआ है. What is written ahead? Let's read this again. The gas in the cylinder reaches a temperature of 100 degrees centigrade. The piston is released and moves towards the right. Temperature remains constant. Perfect. The pressure of the gas now decreases. Wow. We have guessed this पहले. Beta, if you release the piston and it move towards the right, अगर आप piston को release कर देते हो and it move towards the right, what happens? Its volume increases. According to Boyle's law, if the volume increases, the pressure will eventually decrease. So let's see, यही लिखा हुआ है, I guess. I guess this exact thing is written. Yes, pressure decreases. Explain in terms of particles of the gas why the pressure of the gas now decreases. Okay, why the pressure now decreases? You can say as piston moves towards the right, towards the right, what happens? The volume increases and molecules and particles move away from each other, hence less frequent collisions. Less frequent collisions. Perfect, nothing complicated. Let's see the next part. Eventually, the piston stops moving. Explain why. Just listen carefully. Just listen carefully. Please, please, please. I need your undivided attention. You all can visualize that there will be atmospheric pressure acting from the outside. Okay. And if atmosphere pressure is acting from the outside on this piston, this is the area of the piston. And let's say this is A. Can I calculate the force here? Can I calculate the force? I know pressure is equals to force over area. Pressure atmospheric into area is equals to your force. So this green force that is due to the atmospheric pressure will be acting towards the left. Now, when the pressure inside, now please listen carefully. When the pressure inside decreases so much that it equals to the atmospheric pressure. Beta, can you realize the magic here? If the pressure inside equals to the atmospheric pressure, the force that will act towards the right will be equal to the force acting towards the left. ये दोनों forces blue और green same हो जाएंगी. Why? Because both of the pressures have become same, area is same, left right forces same हो जाएंगी. Resultant force will be equal to 0. Tell me, did everyone got this? Tell me, did everyone got this? क्या किया है मैंने यहाँ पे भाई? Yes. Did everyone got this कि मैंने क्या किया है यहाँ पे? Yes or no? 1 second. I didn't write atmospheric pressure, no problem. Balki there is a problem. You had to write atmospheric pressure. How will you state this? How will you explain this? बहुत easy reasoning है. Just follow how I write the answer. Just follow how I write the answer. When the pressure, when the pressure, let's see, when the pressure inside the piston equals the atmospheric pressure equals the atmospheric pressure. What happens? The force from the inside of the cylinder, the force from the inside of the piston gallows, the force from the inside of the I will say the force from the inside of the piston. Yeah, you can say that. The force from the inside of the cylinder, I think, would be better. Is is equal to the force from outside. Hence, a resultant force becomes zero and movement stops. This is an A star answer. Yes, anyone has any questions, any ambiguities? A student directs a beam of white light from a filament lamp towards a glass prism in a dark room. Perfect. भाई एक स्टूडेंट है that directs a beam of white light onto a glass prism. Perfect. And I hope there were no questions in the previous वही वाला. चलो. Figure 4.1 shows the beam of white light incident on the left hand side of a glass prism. Okay. As soon as I see, uh, the reason of studying theory, the reason of studying theory of this chapter of dispersion, उसका एक ही मतलब था. Whenever you see a prism and white light, you understand कि light अब अपने components में break होने वाली है. A screen is placed to the right of the prism. A red light is observed at point R on the screen. Perfect. So red light is observed at point R. कहाँ है भाई red light? Red light is somewhere here. And from theory, I know what? बेटा theory से मुझे क्या पता है? Red light bends least. Okay. And violet light is observed at point V. I know what? Violet bends most. Okay, now let's see what the examiner is asking. Draw on figure 4.1 to show the paths of red and violet light between the left hand side of the prism and the screen at point R and Y. Now, this is a very interesting question. We have to draw the paths. So, just focus a bit. First and foremost, काम क्या होगा? First and foremost, you will draw a normal here. Okay, what we can do here is we can draw a normal like this. Perfect. This is your normal. ठीक है. Now, secondly, what will you do? You cannot draw it like कि भाई हमने अंदाजे से बना दी. No, 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 no. You have to draw it correctly. You have to draw it correctly. So, first of all, what you can do is you can do reverse engineering. You can do reverse engineering. You can say red light की रे कुछ इस तरह से आ रही होगी, somewhat like this. And the violet color, let me find a perfect match for violet. Let's use this. The violet will be coming like this. Oh, not like this. Yeah, somewhat like this. Let's make the red वाली light थोड़ा सा कम bending पे. Hmm. Somewhat like this. Perfect. So first of all, you reverse engineer things. First of all, you reverse engineer things. Beta, up normal say you cannot go from this side to this side. You have to go from the left side to the right side. ठीक है, राइट साइड से लेफ्ट साइड जाना है, लेफ्ट साइड से राइट साइड नहीं जा सकते, गलत ही बनेगी आपकी ड्राइंग. ओके, नाउ लेट्स फर्दर मूव अहेड. नाउ व्हाट एल्स कैन वी डू हियर? We can further draw two normals here. We can say these are my two normals again. Okay. Now what will you do? बहुत simple. Just extend them backwards like this. Like this. See beta, how easily have I drawn this? अगर आप इसको left to right बनाने जाते तो you would have gotten too much trouble. If you would have gotten from left to right, it would have been difficult. Right to left is pretty easy. This is how you will always draw a prism key diagram. Let's move on to part B. ठीक है, let's move on to part B. भाई part B क्या हमारा? Let's see that. State what these observations show about the change in speed of red light and the change in speed of violet light as each enters the glass from air. So you are entering glass from air. What does this tells us about the change in speed of red light and violet light? Now, now. If you notice, if you notice, if you notice, रेड लाइट क्या कर रही है बेटा? रेड लाइट इज बेंडिंग लेस. रेड लाइट इज बेंडिंग लेस. So red light will travel faster in glass compared to violet. देखो, first of all you need to understand, पहला तो difference you will say, first of all you will say, the first difference that you will say here is both red and violet light, both red and violet light slow down in glass. Why? Because glass is more dense. Beta, both red light and violet light slow in glass because glass is more dense. However, the second mark here, आपको यहाँ पे second mark किस वजह से मिलेगा? You will say red light travels faster than violet light, faster than violet light in glass. Simple as that. That's why red क्या कर रही है? Bend least. Violet क्या कर रही है? Bend more. Simple as that. Nothing complicated here. All clear, beta? Any ambiguities here you can ask away. Yes. ये डायग्राम प्रिज्म की डायग्राम, सॉरी प्रिज्म की डायग्राम और दिस रीजनिंग अगर किसी को ना समझ आई हो, द फ्लोर इज ओपन फॉर यू गाइस. बेटा आस्क अवे. लाइट का ये प्रिज्म वाला टॉपिक इज यूजुअली क्वाइट डिफिकल्ट फॉर स्टूडेंट्स, सो इफ यू डोंट गेट इट जस्ट आस्क अवे, नो नीड टू आई shy away. Chalo, let's move ahead. Five other colors of light appear on the screen between red light at point R and the violet light at point V. Perfect. State the name of the five colors and list them in the order from red to violet. What was the acronym? What was the acronym that we need to remember? Roy, Gibb, yeah, Wib Gure. What is after red? Orange. After orange, we have yellow. You can also put in commas here just to show that they are different things. Green, then blue, then indigo, and then violet. Have I missed anything? No, I have covered every color. State how the frequency and the wavelength of the colored light changes going from red to violet light. As you go from red to violet light, what happens to the frequency? Yes, frequency increases. Frequency increases, wavelength decreases. Please remember this. On figure 4.1, okay, on figure 4.1, let's see what the examiner has told us. On figure 4.1, point P is shown immediately next to point R. Acha, point P क्या है? Immediately next to point R. No light is observed at point P. Perfect. But a detector at point P registers radiation reaching the detector. State which region of the electromagnetic spectrum is detected at point P. Okay, okay, okay. So point P is just above the red light. Just above the red light. This will be what? Infrared radiations. Infrared radiations cannot be seen, but they can be detected. एंड चलो यहाँ पे एक और मैं अपनी तरफ से सवाल बनाता हूँ बेटा, एक और मैं अपनी तरफ से आपको एक क्वेश्चन देता हूँ. इफ this was point Q, what will be the radiations detected here? Ultraviolet. Is this entire thing clear to you guys बेटा? मुझे बताओ चैट में, क्लियर है नहीं क्लियर है? Any questions related to this question number 4? I guess question number 4 is finished. Yes, question number 4 finish हो गया. कोई सवाल इसमें? सर हाउ इंफ्रारेड बेटा? बेटा इंफ्रारेड इसलिए बिकॉज इंफ्रारेड्स have a slightly higher wavelength than red light, तो हमने उसको उससे ऊपर प्लेस कर दिया. अल्ट्रा वायलेट हैज़ अ स्लाइटली लोअर वेवलेंथ देन वायलेट लाइट, तो हमने उसको उससे नीचे प्लेस कर दिया. ठीक है. इफ़ यू हैव एनी क्वेश्चंस प्लीज आस्क अवे भाई. अगर नहीं है तो लेट्स फर्दर मूव अहेड. नाउ लेट्स सी दिस. Ultrasound is a longitudinal wave which cannot be heard by humans as the frequency of ultrasound is too high. Now, from theory, what do we know? From theory, what do we know? Ultrasounds have a frequency of what? Ultrasounds have a frequency of greater than 20,000 hertz. Perfect. From theory, we know that ultrasounds have a frequency of what? Greater than 20,000 hertz. Ultrasound waves cannot travel in a vacuum. Explain why. What a beautiful question again. वेरी गुड दुर्योधन भाई, दुर्योधन आज पढ़ के आया हुआ है. वेरी गुड. Why can ultrasounds not travel in a vacuum? Why? Because ultrasound waves are longitudinal waves. Because ultrasound waves are longitudinal waves which transmit through a medium, through a medium by vibrating. भाई अल्ट्रासाउंड वेव्स क्या है? लॉन्गिट्यूडनल वेव्स विच ट्रांसमिट थ्रू अ मीडियम बाय वाइब्रेटिंग पार्टिकल्स. बाय वाइब्रेटिंग पार्टिकल्स, ये लिख सकते हैं यहाँ पे, वाइब्रेटिंग पार्टिकल. इफ नो मीडियम exist, then there are no particles. Then there are no particles. Simple as that. Let's move on to the next part. That is part B. अच्छा क्या लिखा हुआ है? डिस्क्राइब हाउ अ लॉन्गिट्यूडनल वेव डिफर्स फ्रॉम अ ट्रांसवर्स वेव. नाउ दिस आई एक्सपेक्ट इवन दोज टू आंसर जिन्होंने ए नहीं भी लेना. बेटा अगर आपने ए नहीं भी लेना ना फिजिक्स में, तो भी आपको ये सवाल आना चाहिए. दिस इज सच एन इजी क्वेश्चन. कैन ऑल ऑफ यू आंसर दिस भाई? ये बहुत इजी सवाल है. आई वांट ऑल ऑफ यू टू आंसर दिस. हाउ अ लॉन्गिट्यूडनल वेव डिफर्स फ्रॉम अ ट्रांसवर्स वेव. Geniuses, please answer this. Yep, answer this. Everyone write in the chat by answer क्या होगा इसका. How a longitudinal wave differs from a transverse wave. Who will tell me the answer here भाई? कोई जीनियस, कोई ऐसा जिसने पढ़ा हुआ हो, थोड़ा बहुत भी पढ़ा हुआ हो तो उसे आता होगा. Okay, so if you don't remember the definitions, let me bring in the definitions here भाई. Where did I put them? बल्कि let me write it. For a transverse wave, for a transverse wave, you can say the direction, the direction of disturbance. वैसे I expect every one of you to know this. The direction of disturbance is perpendicular to the direction, to the direction in which wave travels. And what about longitudinal waves? I will copy the same definition since I can do that. Oh, control copy, and let's say we paste it here. Perfect. Longitudinal waves are what? Longitudinal waves are those waves. 1 second, let's place it here. Yeah. Longitudinal waves are those waves in which direction of disturbance is what? Direction of disturbance is parallel to the direction in which wave travels. Simple, simple, nothing complicated here. कुछ भी complicate नहीं किया यहाँ पे. Very good भाई. जिसने भी आंसर पहले दे दिया मुझसे very good. An ultrasound transmitter uses a medical scan, produces an ultrasound frequency of this. Okay, so you have an ultrasound frequency of this. In soft human tissues, ultrasound travels at a speed of this. So, beta, you have the frequency, you have the speed as well. Calculate the wavelength of this ultrasound wave. How can we do that? V is equals to F lambda. V is equals to F lambda. What is the velocity? 1500. Okay, what is the frequency? 8.4. And now here you have a capital M for that. Here you have a capital M. But whenever you have a capital M, you cannot ignore it. This is not for ignoring. This means mega. And what are the powers of mega? 10 raised to the power of 6. So frequency will be written like this: 8.4 into 10 raised to the power of 6 lambda. Lambda comes out to be what? 1500 divided by 8.4 into 10 raised to the power of 6. What does the answer for wavelength comes out to be? Any geniuses in the chat? 1.8 into 10 raised to the power of minus 4. 1.8 into 10 raised to the power of minus 4 meters. Nothing complicated, literally easiest question of them all. The ultrasound wave passes from the soft tissue into bones where the speed of ultrasound is way greater than 1500 ms minus 1. Now, please, please, please listen carefully. Ultrasound wave passes from soft tissues into bone. Perfect. State what happens to the frequency and to the wavelength of the ultrasound wave as it passes into the bone. Now here I need your undivided attention. Beta ये 2 marker question was for the A students. जिनका A आना था, it was for them. V is equals to F lambda. We have all studied that. Now in the bones, the examiner has already told you the speed is greater. In the bones, the speed will be greater. If you realize here, बेटा frequency of ultrasound कौन determine कर रहा है? Transmitter. The frequency of ultrasound is determined by transmitter. Frequency is determined by transmitter. So if your frequency is determined by the transmitter and you are not changing the frequency, that means frequency is constant. That means velocity is directly proportional to lambda. Frequency remains constant. If velocity increases, that means lambda will increase. Is question number 5 clear to all of you? Yep. Chalo, let's move on to question 6 भाई. Question 6 पे move on करते हैं भाई. Let's move ahead to question 6. Yeah, let's see this. Another good question. A bar magnet can rotate freely around a thin rod about its center. Perfect. A bar magnet can rotate freely about its center around a thin rod. The bar magnet is at rest on a frictionless horizontal surface in a laboratory which is shielded from the Earth's magnetic field. Perfect. State a substance from which the bar magnet could be made. Yes. Yes. How can we make a bar magnet which is shielded from the Earth's magnetic field? Hmm. Bar magnets are always made of steel. Bar magnets are always made of steel. The thin rod, okay, अब देखो अब जरा अच्छा सवाल है. Now this is a good question. Please pay attention. You have to draw a diagram as well. Just pay attention. The thin rod, okay, is perpendicular to the top and bottom surfaces of the bar magnet. Perfect. Figure 6.1 shows a view from the above of the bar magnet with the north pole, the south pole, and the thin rod labeled. Perfect. You have the north pole, you have the south pole, and you have the thin rod here. Perfect. Draw on figure 6.1 to show the pattern and the direction of magnetic field around the bar magnet. What a beautiful question. You have to draw magnetic field lines around the bar magnet. How will you draw magnetic field lines around the bar magnet? You will first of all draw magnetic field lines from north to south. From north to, oh, I am really bad at drawings. From north to south, like this. North to south, north to south. Now, if you draw this, you will only probably get 1 marks or 2 marks because you are missing one thing here. You also have to show field lines originating from the north like this and field lines going into the south like this. Perfect. This should be your drawing. Nothing complicated here. Perfect. Chalo. Let's further move ahead. Yeah, we have this. Perfect. An electromagnet, perfect. An electromagnet is switched on and a strong magnetic field is created around the magnet. Perfect. एक electromagnet switch on हो गया है and a magnetic field is created around the bar magnet. Perfect. Now here you have to understand the meaning of the word electromagnet as well. What is an electromagnet? It is a temporary magnet. It is a temporary magnet. Okay, let's see. We know this from theory. I don't know whether it will be utilized or not. We will see just now. Figure 6.2 shows the direction of the strong magnetic field due to the electromagnet is from left to right across the page. Perfect. Draw an arrow on 6.2 to show the direction of the horizontal forces that act on the poles of the bar magnet. Perfect. So we have to mark the direction of the force that will act on these bar magnet. Perfect. What can we do here? Hmm. Yep. What can we do here? Yes. If you notice, if this is the magnetic field direction of the electromagnet, this will be the north pole. This will be the south pole. These are the north field lines. These are the south field lines. How will you draw the arrows? बेटा नॉर्थ पोल जो इस मैग्नेट का है दिस विल रिपेल द इलेक्ट्रोमैग्नेट and the south pole of this magnet will also repel this electromagnet. So how will you draw the lines? Whenever you repel, you go away from the magnet, somewhat like this. You go away from the magnet. You go away from the magnet like this. Is this question clear, beta? C का part 1 clear है? Is this question clear to you guys? This is your force F. This is your force F. Perfect है. एक second, let me see. नहीं है clear. Describe and explain what happens to the bar magnet when the electromagnet is switched on. Now, if you have studied थोड़ी बहुत physics, you will know what will happen to the bar magnet when the electromagnet is switched on. Can you see these two forces will generate a moment? Can you see these two forces will generate a moment? Yes. And it will cause the magnet to rotate. These two forces will cause a moment and will cause the magnet to rotate. बेटा कटिंग इफेक्ट यहाँ पे नहीं आएगा. You Can you see these two forces acting on the magnets will produce a moment? As they produce a moment, they will cause the magnet to rotate. बेटा magnet आपका rotate हो जाएगा due to these two forces. Sir, what are you saying? I cannot understand that. बेटा सब चीजें छोड़ दो. Assume that this is a meter rule. Assume कर लो ये एक meter rule है, not a magnet. You are applying a leftward force like this and a rightward force like this. This will start to rotate because you are generating a moment here. So you can write this here. The magnet starts to rotate. In which direction? You can also tell the direction. The magnet starts to rotate in which direction? This is the anti-clockwise direction. Anti-clockwise direction. The magnet starts to rotate in the anti-clockwise direction. Why? Because the forces generate a moment. Because the forces generate a moment. Okay. Will the magnet keep on rotating or will it stop? Beta, will the magnet keep on rotating or will it stop somewhere? The magnet will stop rotating when we are in a position like this. Where should I draw this? Yeah, I think this will be great. The magnet will stop rotating when this becomes south pole, this becomes north pole, and the magnet becomes parallel to the magnetic field lines. Beta, if the magnet becomes parallel to the magnetic field lines, these forces F will not occur. If these forces F not occur, the moment will not be generated. So you can also write this here. The magnet stops rotating when the magnet becomes parallel to the magnetic field line, becomes parallel to magnetic field lines. Simple. Now let's move on to your favorite topic, that is electricity. Now we move on to electricity भाई. Electricity पे move on करते हैं चलो. A filament lamp is connected to a 12 volt power supply and transfer 24 watts of power. Calculate the current in the lamp. You have to calculate the current in the lamp. You will say what? Power is equals to IV. Power is what? 24. Voltage is 12. Current comes out to be 2 ampere. Simple as that. Calculate the resistance of the lamp. Again, very easy. You have the current, you have the voltage. V is equals to IR. Voltage is 12, current 2, resistance comes out to be 6 ohms. Simple as that. Literally, 4 फ्री के मार्क्स दिए हैं बेटा उसने. 4 फ्री के मार्क्स दिए हैं उसने यहाँ पे आपको. चलो, let's move ahead. A student has a battery of electromotive force 12 volts perfect. The student uses the battery in a circuit with 12 volts filament lamp. Perfect. The lamp is connected here. To obtain a range of suitable readings and plot current versus voltage graph for the lamp. Okay. Figure 7.1 shows the battery and the filament lamp perfect as expected. On figure 7.1, complete the circuit diagram of a suitable circuit. You will need to add additional components. Okay. So, beta, first of all, some things are pretty evident. You want to plot the current versus voltage graph for the lamp. So, if you want to measure current, you will need an ammeter. If you want to measure current, you will need an ammeter. And if you want to measure the voltage, you will need a voltmeter. But there is still one component missing. If we make this circuit, we will only get one reading of current. If we make this circuit, beta, we will only get one reading of current. and one reading of voltage. If we create this circuit, we will only get one reading of current and one reading of voltage. बेटा अगर हम ये सर्किट क्रिएट करते हैं वी विल ओनली गेट वन रीडिंग ऑफ वोल्टेज एंड वन रीडिंग ऑफ करंट. हाउ कैन आई गेट मल्टीपल रीडिंग्स ऑफ वोल्टेज एंड करंट? By adding a variable resistor here. By adding a variable resistor here. This variable resistor, let me write it here. This variable resistor allows us to change resistance of the circuit, allows us to change resistance of the circuit. Hence, we can get multiple values of voltage and current. Simple as that, nothing complicated. You have attached a variable resistor, you have attached a voltmeter, you have attached a ammeter, you are good to go to the next question. Next question पे बढ़ते हैं भाई. 1 second. Sir, can we also use rheostat? Beta, rheostat and variable resistor are one and the same thing. Sir, potential divider use कर सकते हैं. Yes, do rather than you can use potential divider as well. But that will create an even complex circuit. तो मैं usually variable resistor या rheostat are one and the same thing. We use that. Okay. So let's further move ahead. On figure 7.2, draw the shape of the current voltage graph for the filament lamp. Okay. You have to draw the current versus voltage graph for the. What is the direction of current? Do we have to tell that as well? ये भी बताने हमने. If we have to tell the direction of current, it will be from positive to the negative like this. ये आ गई आपकी direction of current. ठीक है. If we have to tell that, I don't think we have to tell that here, but you can mark it anyway. ठीक है. Okay, now we have to draw the shape of current versus voltage graph for a filament lamp. For this, you need to be well versed with the theory. For this, you need to be well versed with the theory. Beta, what have I told you guys? What have I told you guys in like different sort of lectures? क्या बताया मैंने? That filament lamp is a non-ohmic conductor. Filament lamp is a non-ohmic conductor. Let me take you to the notes here. नोट्स पे ले जाता हूँ थोड़ी सी एक्सप्लेनेशन दे देता हूँ सो दैट यू नो एटलीस्ट कि क्या होता है. फिलामेंट लैम्प is a non-ohmic conductor. Where do we have it? Yeah. Filament lamp is a non-ohmic conductor and its resistance increases with the voltage. So beta filament lamp का voltage versus current graph is an increasing curve like this. And the filament lamp का current versus voltage graph is a decreasing curve like this. So we have to draw this on the examination. Chalo, let's draw this. Perfect. So somewhat like this. For this, he is giving you how many marks? 2 marks. Literally, I don't know what the examiner is doing here. इतने easy marks उसने छोड़े हुए. State what happens to the resistance of a filament lamp as the applied voltage increases and explain one reasoning for this happening. बेटा अभी मैंने आपको नोट्स में दिखाया है. What happens to the resistance of the filament lamp as the voltage increases? The resistance increases. So first of all you can say that. First of all आप ये बता सकते हो यहाँ पे. You can say as voltage and all these annotated past papers भाई ड्राइव पे अपलोड हो जाएंगे. Don't rush to copy. Just try to focus, sit back, relax, and understand. As voltage increases, your resistance increases. Now, why is this the case? Explain one reason for this happening. Why does this happen? Why does the resistance increases as the voltage increases. You will write a very simple answer here. You will say, as voltage, now please see what I'm writing. Voltage increases, temperature increases. Temperature increases. Perfect. This causes, this causes the vibrations. This causes the vibrations of molecules to increase. This causes the vibration of molecules to increase. And as the vibrations of molecule increase, what will happen? The molecules, as the vibrations of molecules increase, क्या होगा बेटा? As the vibrations increase, or you can say the vibration of molecules increases, and this hinders the flow of electron. This hinders the flow of electrons. Nothing complicated here. Is question number 7 clear to all of you? Then we move ahead to the next question. बेटा क्वेश्चन नंबर 7 में किसी को कोई मसला? अच्छा, why can hydrogen 3 not decay by emitting alpha particles? Huh. Why can hydrogen 3 not decay by emitting alpha particles? Yes. Because hydrogen 3 has only one proton. Alpha decay में कितने protons चाहिए होते हैं? Two protons. Does not have an alpha nucleus. Yes, you can say that. Because hydrogen 3 only has one proton, or you can say it has only three nucleons. Three nucleons. Simple. Let's move ahead by hydrogen 3 decays by the emission of beta particles to make an isotope of different element. This element is represented in the equation by Q. ठीक है. अच्छा, this meeting will end in 20 seconds. You will have to join again. Complete the nuclear equation for the decay of hydrogen 3 decays by beta particle emission. Okay, by beta particle emission to form an isotope of a different element. This element is represented by equation Q. Perfect. Complete the nuclear equation for the decay of hydrogen 3. Now, please apply some logic here. The symbol of a beta particle is what? Negative 1, 0. Whenever beta particle decays, your mass number remains unchanged. This 3 will remain 3. Your proton number increases by 1. 1 plus 1 will become 2. This is your configuration of Q. Simple as that. State the name of the element represented by Q. Now, this was a difficult question because this was related to chemistry. This was related to chemistry. Which element is represented by this symbol Q? This has a proton number of 2. This is helium. This is helium. The half-life of hydrogen 3 is 12 years. Okay, what do we mean by 12 years? या half-life का क्या मतलब होता है भाई? What is meant by half-life? Time taken for the number of atoms या count rate to half. What is the definition of half-life? Time taken for the number of, okay, for the number, बेटा just focus on what I'm trying to write here. Annotated past papers वैसे भी uploaded हो जाएंगे ड्राइव पे. Time taken for the number of atoms slash count rate to half is your half life. Yeah, Abdullah, I haven't seen this type of a definition in marking scheme. वैसे कहने के लिए सही है लेकिन never seen that in marking scheme. So ये वाली जो है वही लिख लेना. A sample of hydrogen is placed, okay, on a laboratory bench next to a Geiger-Müller tube. Perfect. And counter. The count rate is recorded at the same time on 4 successive days. Wow. Figure 8.1 shows the count rates obtained. कभी 98 आ रहा है, कभी 89, then 93, then 85. State why the count rate increases and decreases. Very, very easy. बेटा मैं दिखा देता हूँ. One second, one second. Why the count rate increases and decreases? Because radioactivity is random. You can say the count rate increases and decreases due to the random nature of radioactivity. Perfect. Perfect. चलो. You can see part कौन सा दिखाना था भाई? Part 2 वापस दिखाने. Do rather than here you have it. Anyone has any ambiguities in this question number 8, they can ask me right away. बेटा कोई ambiguities हैं, you can ask me right away. We are moving on to the last question of today's past paper. Question number 9. चलो. Any ambiguities here भाई? आगे बढ़े. चलो. Let's further move ahead. Let's further move ahead. Okay, a stable star in a distant galaxy has a mass more than 15 times the mass of the sun. Okay, what is this star? बेटा अगर आपका mass 15 times the mass of the sun होगा, then you will be a red super giant. If you have a mass that is 15 times the mass of the sun, then you will be a red super giant. Okay. And if your mass, चलो मैं यहाँ पे लिख भी देता हूँ somewhere here on a blank page. If your mass is less than 8 times mass of sun, then you will be a red giant only, a red giant star. However, if your mass is greater than 8 times the mass of the sun, you will be a red supergiant. State the name of the nuclear reaction that occurs at the center of the star and describe this nuclear reaction. Okay. Which nuclear reaction occurs at the center of the star भाई? सिर्फ आपने अगर ये बता दिया कि कौन सा न्यूक्लियर रिएक्शन अकर करता है, यू विल इजीली स्कोर 1 मार्क, बाकी के 2 मार्क्स डिस्क्रिप्शन के. सो विच टाइप ऑफ न्यूक्लियर रिएक्शन अकर एट द सेंटर ऑफ द स्टार? न्यूक्लियर fusion. And what happens in nuclear fusion? Can anyone tell me? Hydrogen isotopes. Hydrogen and if you want to really, really achieve an A star or probably a distinction, you will say hydrogen isotopes such as 21H and 31H join together to form a helium nucleus. Perfect. Explain how this nuclear reaction helps to make the star stable. Okay, how this nuclear reaction helps to make the star stable. Fusion reaction releases higher amount of energy. Nuclear fusion reaction releases energy. This energy causes the temperature to increase. This increase in temperature causes an outward force. This outward force balances the inward gravitational force. How will you write it step by step? You will say the nuclear. See, this is a 3 marker question. Nuclear fusion reaction releases energy. This energy causes the temperature to increase. This increase in temperature, or you can connect this statement again here, this causes the temperature to increase and results in an outward force that balances that balances the inward gravitational force. That balances the inward gravitational force. सिंपल एज दैट आई होप अब आंसर राइटिंग समझ आ रही होगी किस तरह आंसर लिखने हैं एवरीथिंग विल बी अपलोडेड ऑन ड्राइव एज वेल सिर्फ समझो बेटा आंसर किस तरह लिखने as a massive star approaches the end of its life it stops being stable and became a red supergiant we have already reduced this यहाँ पे बेटा this will increase your confidence जब भी आप सवाल देख के खुद ही कोई चीज डिड्यूस करोगे और बाद में वही चीज लिखी हुई होगी इट विल इंक्रीज योर कॉन्फिडेंस मल्टीपल टाइम्स state why the nuclear reaction can no longer keep the star stable okay why the nuclear reaction of fusion cannot keep the star no longer stable why because the hydrogen runs out because the hydrogen runs out describe what then happens to the red supergiant भाई हाइड्रोजन रन आउट हो जाता है उसके बाद रेड सुपरजायंट को क्या हो जाता है I have written this multiple times in the notes. Once the hydrogen runs out, a red supergiant explodes. Once the hydrogen, oh, what happened here? Okay, once the hydrogen runs out, the red supergiant, the red supergiant explodes and forms what? And forms a supernova. The red supergiant explodes and forms a supernova. What else happens? What else happens? The red supergiant produces heavy metals which form a planetary nebula. इसके बाद क्या लिखोगे? You will also write it also produces heavy metals that turn into planetary nebula. Simple as that, nothing complicated here. And if you want to further write something, you can say this further converts into a black hole or a neutron star. Simple as that. What has happened here, bhai? What is happening here? Yeah. This further gets converted into a black hole or a. Why does this keep on? Simple. This marks the end of the paper. Any questions that you have in this entire paper, ask away.